Testing, 1, 2, 3.
Little red light. Okay, good. All right, this is the rest of Chapter 4, which we are going to go through pretty quickly. You should already know what metadata is because I required you to have that in your entity relationship diagram. And metadata is just the background information about your fields. Okay? But I want you to know what the word metadata means for the exam. It's background information about your fields. In other words, what kind of data do they contain? Is it numeric? Is it text? Is it a date field? Etc. Is it a yes-no field? And don't worry about that. I jotted that on your entity relationship diagram. I didn't really take off points for it because we haven't gotten there yet. But particularly for text fields, I wanted you to give me a reasonable number. And it's up to you. What do you think the longest last name might be? 40, 50 characters? I don't know. Something like that. Right? So each field in a table has a name, but it also has the kind of data it stores and the length of the data if it's text. And there's other characteristics that I'll show you when we get into Access. So, what are the parts of a database management system? What is a database management system anyway? Well, a DBMS, for your purposes, is just a program. That's it. The program we're using is Access. Our DBMS is Access. And what a DBMS does is it actually creates the physical database and it allows you to enter or change the data, and it also allows you to create some other cool things that we're going to do in the final part of the project, like forms and reports and queries and so on. So all database management systems are just software that allow you to do these things. Okay. I do want you to know who a DBA is. A DBA is short for Database Administrator. So in the real world, the software engineer meets with the users of a new database. Okay? And the users would tell me, what data do I need to store and why? I would go back to my desk and I would sketch out an ERD of the database and come back to you and get your approval. Does this look right? Okay? At that point is where the database administrator takes over. And they actually create the database. They create the tables. They create the fields and the metadata, according to what I tell them. Okay? So you guys, for the purposes of our Access assignment, are going to be DBAs for a day. DBAs. Very, very important job. When I worked at Texas Instruments, the DBAs were some of the smartest human beings I ever met. They were actually very intimidating, and they made a lot of money. And I'm not going to go through all these things, but if you think about it, it makes sense. Database administrators have a big responsibility. They are responsible for a corporation's data. And next to the people, the heart of a business is its data and information, right? So keeping it accurate, safe, secure, and correct, that's all the job of the database administrator. Really important job. Now the actual program, the DBMS that we're going to use is Microsoft Access. And it is a collection of forms, reports, and queries. So what is a form? Let me describe it to you this way. I'm sure that you have from time to time picked up a magazine and one of those little index card size things falls out. And those are actually, if you want to subscribe to that magazine, you can fill that out and drop in the mailbox. It's got like prepaid postage, right? That's a form. Those things that fall out of the magazine. You know that if you want to sign up and get that magazine, that's a form. So some poor data entry clerk gets that, and she has to enter that data from that form, that paper form, into the database. And you would be a new customer, right? Okay, that's a form. So a form is just an online way of inputting or changing data. That's all. And you guys know what a report is. It's just a nicely formatted peek inside of your database. And you're going to create a report for your big project. One report. It just looks really nice and pretty and so on. For the exam, a query is a question. Just remember that. Q equal Q, query equal question. I have used this example in the past. You go to the bank, you want to withdraw some money. I don't know my account number, neither do you probably, right? So the bank teller might ask you what's your social security number. So she would pull up a query that might say something like, pull up account by social security number. So she would start that query, enter your social security number, hit the enter key, and voila, there's your account. So a query is a question. Or I guess it could be a statement. Show me something. Show me a person's account based on their social security number. Okay? So I believe you have to create 5 queries in your 50-point database. You have some leeway about what you create, but there are certain requirements for the 5 queries. Application programs also access databases, but since we're not programmers, we're kind of skip over that for right now. This is kind of interesting and may or may not appear on the exam, so let's cover it. It's called the lost update problem, and it's kind of interesting. All right, let's say that Danny and Keaton, we have a central database at work, and they both work at the same place. So Danny goes and gets this document and pulls it up on her computer and starts making changes to it. In the meantime, Keaton does the same thing. He goes and gets a copy of this and starts making changes to it. Okay? So they both have a copy. They're both making changes to it. Now, Danny uploads her version back up to the library. And shortly thereafter, Keaton uploads his version. What just happened that's bad? They both had a copy of this. She made a bunch of changes and uploaded it. Okay? Now, Keaton's got a copy and makes a bunch of changes, and he uploads it. What happened that was bad? Yeah. Her changes, gone. His stepped on it, right? It's just like you guys, if you save a Word document over an existing Word document, only the latest one is going to be saved. That's the lost update problem. However, that being said, most databases have got a lock. In other words, if somebody pulls up a record to modify it or delete it or whatever, it's going to lock everybody else out. Okay, it's like a protection. But that's the lost update problem. Okay, so we're talking about relational databases here. And we are going to be using a relational database called Microsoft Access. So it obviously will fit on a PC, as will whatever data you enter into it. That's just not going to work if you have a company with thousands of employees. It's not. Access wasn't built to handle thousands of employees. It wasn't. So what I'm saying is that there are lots of other databases out there that handle large volumes of data and large numbers of users. FYI, because it might be on the test, DB2 is an enterprise database. PeopleSoft is an enterprise database, which I think we use here. PeopleSoft. Okay? So there's lots of other relational databases, but we're going to use kind of the baby version. Don't confuse the Word database with the DBMS. A database is actually a physical collection of data. It's a file. So what you're going to be uploading this Sunday is going to be a database. It's not going to be finished, but it's going to be partially finished. You're going to upload a database. And then your final project, you're going to upload a database, right? Now, the DBMS is the software that allows you to create that database and all the things in it. So, don't get them confused. So, once again, in the real world, this is how it goes. There's a need in the business for a new database, or maybe we need to update the database. Maybe it's slow. Whatever the reason is, we need a new database. Okay? So I'm a software engineer, and you guys are all accountants. I don't know a thing about accounting. So I will go to you and ask you, what information do you need to store? How is it related to each other? Why do you need to store it? I know the right questions to ask. So you guys, the users, are going to drive the design of the database because it's for you in the end, right, ultimately. So then, once I get with you, I'll go back and I'll make my entity relationship diagram, and I'll come back to you and say, now, does this look right? Is there anything missing? Is there anything you need to add? And you accountants will say, it looks wonderful. Beautiful, perfect, perfect. And I go, okay, that's it. I'm pretty much done. Then, who takes over from there is the database administrator, because they're actually going to build the database, which is going to be the tables, the fields, the metadata, the relationships, all that stuff. The DBA is going to do all that. And then we'll figure out who's going to enter the data. It might be you guys, the users, or I might help you. We'll figure that out. But it all starts with the user. Okay? So after you create the picture of your database, you turn it into a physical database. That's why on Thursday, I want you to walk in here with a perfect ERD. Perfect one. So hopefully you guys can actually start working in Access on your project. Okay. So you already know what an ERD is, since you already did it. It's just a picture, right? And you know what entities are. Entities are groupings of things that are related. And attributes are going to later turn into fields. Here's a new word for you. Might or might not be on the exam. Cardinality. Cardinality. And it may have been a little confusing for you when you read it in the book. So I'm going to give you the Galusha definition. All it is how the tables are related. In other words, that crow's feet that you drew between the tables, that crow's feet, that's the cardinality. And for our purposes, we're always going to use one-to-many. So one university has many classes. One class has many students. One-to-many cardinality. All right? Now I want you to look up here if you don't have the slides in front of you, because, whoops, see my little pointer will work here. See this right here, where it's crow's feet on both ends? Let me tell you right now, that's bad. Bad. That's called a many-to-many relationship. And in the real world, I've experienced those, we end up having to create a workaround involving another table. So it's a little more technically challenging. But this is not good. This means a department has many advisors. But if you read it backwards, it says an advisor can belong to many different departments. That really isn't true, though, is it? No? Okay. But this double crow's feet thing is bad. Bad. So once again, we talked about this before, but if you'll make note of this, who remembers what this little dash means? No, it means must. This dash means must, and it's really only used when you read it backwards, okay? So an advisor must belong to a department. Must. Vertical line means must. And who remembers what the O or 0 represents? Or when you read it this way, the regular way? 0, or optional. 0 or optional. So a department can have 0 or many advisors. And that's true if you think about it. Like the HR department here at the university. Do they have any advisors that advise students? No. Alex, please join us. So the O means optional or 0. So just keep that in mind. Another word for the exam, normalization. I know there's a lot of new terminology here. And let me put it this way. Normalization, it probably isn't the greatest word, but that's the word they use. I used it way back when too. But really the word should be optimization. So normalization means optimization. So what does that mean? Essentially it means this. There will never be any data duplicated in your database. If I had a database with student names, for example, that had student name field in it, there's not going to be 2 tables with student name. And why would it be bad to have 2 different tables in the same database with student name in it? Why is that bad? Somebody co-op to me. If we have a database and we have this table that's got student name and we have this table that's got student name. Okay. She said they're all the same. All the names should fall into one table. And that's exactly true. So you should never have student name in more than one table. For one thing, you might update this student name over here, and this one might not get updated. For example, one of you guys, girls, gets married, so we got to change your name. We change it here, we don't change it here. Now we've got 2 different student names to represent the same student. That's bad. So, normalization means really optimization, no duplicates. But it takes it actually a step further. And it also means that there's going to be no inaccuracies. No inaccuracies. And remember from way back when, the more accurate your data, the more accurate your decisions that come from that data. Makes sense, right? Garbage in, garbage out. Normalization. Normalization goes hand in hand with another term, data integrity. And integrity means goodness, correct? So that should give you a hint if you see it on the test. Data goodness. So data is good if it's correct, right? Correct. It's accurate. So the term data integrity means that the data is accurate. In other words, you're not going to have a student over here who got married and we changed her last name, but the same student's in another table and still has her old name. It's going to be accurate. Okay? I have seen this on the test, so you should make a note of this. I don't like it, but they didn't ask me. And it's actually been this way since I was in college, truly. How do we represent relationships? Well, in an entity relationship drawing, we use like the crow's feet, right? But here's another way. 1 to n is like a line with crow's feet, okay? It's the same thing. It means 1 to many. Why isn't it 1 to m? I have no idea. This makes more sense, doesn't it? 1 to m? No. 1 to n. Now we have n to m. That's many to many. And remember, that's bad. So just remember, what you want is 1 to n, and n to m is bad. I already mentioned this. Users, you guys, you accountants, are the final judge to a database's design. Absolutely. You give me the stamp of approval on the entity relationship diagram. I hand that over to the DBA, and that person builds the database and so on. Okay, now let's stop for a moment. One of the other things that I did yesterday was I sent you guys your grades so far in the class. So I just would like to mention that to you. Don't panic if it's not where you want to be, because we are not even getting started. You know, we have a lot of points to go. Lots. So don't worry. However, that being said, if you're really far behind, you should strongly consider 2 of the big extra credit assignments, and one of them is reading the book Big Data, and you have to write a paper on it. It's not really a book report, it's more of your thoughts on the book. So, this next section is about big data. Not the book Big Data, but the concept of big data. Big data wasn't around when computer science first came to be. Big data really evolved as the internet came into existence, particularly Google and other solutions. And big data is a significant paradigm shift, and it is on the test, definitely, because I like it. Big data is a big paradigm shift in how we think about data as a whole. So, let me give you this example. If you're a scientist and you're researching the effects of some chemical on plant growth. So if you could remember from way back when, you would have a control group, right, where you wouldn't add the additive. And then you would have the experimental group where you would add some amount of additive, and you would keep up with all these records of how much it grew and how fast and all that, right? Okay. So you're going to get very specific data. And the purpose of that experiment is to extrapolate out to other plants, right? Maybe some hormone that we're testing. We can't test it on every plant in the world, right? But we're going to test it on one. And we're going to hope that those results apply to every other plant. Okay? So, that's the premise. It's very specific data. Big data is completely different. You should jot this down for the test. Big data is completely different. It doesn't rely on specific recorded data. Okay? In fact, we call it fuzzy data. Fuzzy. So, in general, the Center for Disease Control is responsible for predicting where the flu outbreak is going to hit hardest and, estimates of how many people are going to die and that sort of thing. The CDC does that. Okay, and they haven't always been very accurate, right? Because they have to go on historical data. Now, think of this. I don't know about you guys, but when I suspect that I'm getting something, the first place I'm going to go is to Google. And I'm going to type in my symptoms and try and figure out what it is. All right. So what was discovered in the book Big Data is that Big Data was able to more accurately predict the flu outbreak than the CDC. And why do you think that might be? Search engine. So if you think you're getting the flu, what might you type into Google? Flu symptoms. Or what is the difference between a cold and the flu? Or anything that's got the word flu in it, right? So what happens is that we were able to take all of that search data and the locations of where it was performed, general locations, and very accurately able to predict where the flu was going to hit hardest. Okay? That's big data. And it didn't matter if the person typed flu symptoms or what's the difference between a cold and a flu. That's what makes it fuzzy data, right? It's not always going to be the same. But it's a paradigm shift from looking at very detailed data in a database and trying to come up with predictions for your business to looking at data a completely different way. Not only your database data, but your Excel data that's on people's desktops, your Word document. If you could cram it all together in some big database and do searches on it, you could probably get more accurate information. Okay? That's big data. Let me give you another example because it's kind of funny. Walmart discovered that if there was a hurricane coming in an area, that sales of Pop-Tarts went through the roof. I think that's kind of interesting. I don't know why, but I guess people want Pop-Tarts around when they feel like they're going to be, homebound or something like that. So, how could Walmart use that to their advantage? Knowing that. Pop-Tart sales go way up if there's a hurricane coming.
Mark them up.
Okay, they can mark them up. That would be very nice, but okay.
Make sure they have plenty.
Stock more, absolutely, so you don't sell out. Or how about a big fat display right at the front of the store where you're checking out so people can grab their Pop-Tarts right when they're checking out, right? And there's lots of examples, really fun, interesting examples of what you can do with big data that you can't do with regular databases. So, if your grade was less than you expected, and if you really want that jump, then I would advise you to start reading the book, Big Data. Start reading it now. I'll send you guys that information a little bit later, so I don't have to interrupt this. But read the book, Big Data. It's paperback. It shouldn't be too expensive. Okay. Pardon?
Did I miss that? Did you say it's an assignment or that's what
It's an extra credit. Extra credit. So I'm going to skip all this. However, before we take our break real quick, I would like to tell you guys that I'm disappointed that not everyone took advantage of the extra credit opportunity for doing something nice, because really you could have done just about anything to get points. But I was very, very touched by your answers, all of you that participated, very touched. And in fact, I gave you feedback, so please go in and read the feedback that I gave you. So I gave everybody feedback. So some of you really went above and beyond what I required. And a lot of you just did very simple things, very simple things. But thank you all. I like those, in particular, I like those that people call their grandma or they call their mom, because I'm a mom. And I never hear from my rotten kids unless they want something, So when they call me and just say, "Hi, Mom, what do you do? And I love you," it's like, I'm starting to boo-hoo already, So you should call your mommy or your daddy or grandma or grandpa. So that was really touching. All right, so please come back a quarter after and be prompt. And we are going to jump right into access. So Matt, if you would, please press pause.
We're doing a custom or a blank?
Okay, so first of all, click on Start Programs and look for Microsoft Office. Start Programs, Microsoft Office. And then click on Access, 2013 Access. All right? And it will bring you to this screen. So while that's coming up, most Microsoft Office products have templates that are kind of pre-formatted things that you can use and sort of change what you like and delete what you don't like and so on. Like, for example, resume templates and things like that. Fax cover sheet templates. Well, similarly, Access has got templates too. But we're not going to use a template. We're going to start from scratch. So, with your notebooks open, start Access, and then click on Blank Database. Step 1, Blank Database. Now, I want you guys to name your database, your last name, and some of you, there might, if you have brothers or whatever, you might put your last name, first name. I'm just going to call it Galusha because I'm the only one. Well, actually, Galusha J. And then click Create. So if you're just glancing at Access for the first time, you'll notice that it looks very much like other Office products, correct? It's got tabs across the top and different icons that you can pick and choose from. So real quick, we'll look at the Home tab. These are just some of the things that you can do. The number 1 is the View. So just for fun, I would like you to click on the View. And typically you're going to have multiple ways of looking at things in Access. Multiple ways of looking at things. So we're in Datasheet View, which looks just like Excel. So we're going to stay there for right now, just because I want you to be comfortable with it. But later on, we're going to go into Design View just to make sure that you're familiar with it. Bless you. Most of the other stuff we're not going to use. Create is going to be very important to us. Especially creating more tables. Later on, after we have all our data entered, we're going to create forms, we're going to create queries, we're going to create a report. So this is going to come in really handy, the Create tab. I'm not going to fool with external data. However, FYI, if any of you have already started entering your data in Excel spreadsheets, I can show you how to import that data so you don't have to retype it. Okay? Database tools we're going to use mostly for its relationship, which we're going to do in a moment. Database tools relationship. And quite frankly, I don't mess too much with fields or tables. So let's just go back to the Home tab. But as you can see, it's got menu items just like all the other Office products. They're just specific to Access. So when you start Access with a blank database, Bill Gates and company thought it was wise to, number one, automatically create a table for you. Thank you very much. Not only that, but he got wise and said, I'm going to create a table and I'm going to give you a primary key. Every time you create a table, I'm going to automatically give you a primary key. And remember, one of the rules is all tables have to have a primary key. Always. Right? Okay, so we're already halfway there. So we're going to use the university classes and students example, and we're going to abbreviate it just to make things go a little faster. So the next step is just click on the word ID, which is the primary key, and we're going to type over it with the name UNIV ID, University ID. Okay? I'm going to go over to the next column, which is the next field, right? And for fun, let's see. I'm going to just use university website. I'm not going to put in all the fields. So jot this down. Click on the little down arrow. And whatever field you want to add next. This is the actual metadata, or part of it anyway. So university website is text, or alphanumeric, right? So I'm going to choose short text. For the most part, yeah. And I'm going to type over the name with University Web. Oh, what? You know what? I'm such a dummy. I forgot names. Let's backspace. What do? University name. It's also short text. Then I'm going to add short text. University Web. Okay. So you guys are going to have at least 6 columns, because I don't count foreign key. Remembering that address, first name, last name are considered one, right? All right. So once you have finished entering all of your columns, jot this down. Right-click on the table, table 1, right-click on table 1, and close. Right-click, close. Save the changes, but stop here. Right-click, close, and save the changes. This is the opportunity for you to rename the table. You'll have other opportunities in case you hose it up, but for now we're going to name the table University. Okay. So you'll see that over on the left, we have one table named University, and if we click on it, double click on it, it brings up our university table with the name and just the website, right? No data. No data, right? So I'm just going to close that. All right, now your second table. So jot this down. Click Create Table. And it's actually going to create an identical, a duplicate of what you started with, right? Table 1. And we're going to do exactly the same process. Except this one's going to be classes, right? So, click on ID. And we're going to call it Class ID. Then I'm going to add class name, which will be short text. And I'm going to skip the rest of the fields for now, except the most important one, which is the foreign key. Exactly. And there's nothing magical about a foreign key. It's just a field. All right? All jot this down. The very last column must be your foreign key. Not all tables have foreign keys, do they? But this one does, because universities have classes. Therefore, classes have a foreign key. And always and forever, the foreign key is going to be numeric. So put a big asterisk, because some of you will hose that up. The last field should be your foreign key, and it should be type numeric. And I'm going to name it Class University ID. So, the last field should be your foreign key. It should be numeric. And once again, we're going to right-click, close, and save, and name it. What's the name for this one? Class, right? Universities have class. This is the class table. So now, look over on the left. We have a university table and a class table. University table and class table. So here we go a third time. Create table. Type over ID, and the last one is student. So we're going to call it STU ID. And I'm going to add student last and student first. Okay? So they're going to be short text. STU last name. Short text. STU first name. And again, remember, you're going to have a lot more columns. These columns are going to come, these your columns are your entities in your ERD. The very last column must be your foreign key. And it's always going to be what kind? Numeric. Always. So, we're going to call it STU class ID. So just remember, I'm just cutting out a lot to make things faster. And once again, right-click on the table name, close, and save it. and give it the name, where are we at? Students. So voila. We have university, class, and student. And don't worry about the order of these. Okay? They're not really relevant. As long as you have 3, each one of them has all of your fields and so on. All right. Now, draw a line on your page, and I want you to write how to create relationships. Having a foreign key is not enough. Having a foreign key is a big, important part of it, but it is not enough. Actually, in Access, you have to create the relationships. So this is how you do it. Jot this down. Click on Create. I'm sorry, my bad. Click on Database Tools. And then Relationships. Database Tools, Relationships. What it's going to show you is all the tables that you've created. So, although you can move them around after you add them, just add them in the order that they're on your ERD. Okay? Just put them in, add them in that order, whatever they look like on your entity relationship diagram. Right? So for me, it's university, class, student. So I'm going to click on university, add, then class, add, then student, add. Whoops, I added it. Okay. University, class, student. Just so it looks like it does on your entity relationship diagram. However, if you hose it up, watch this. You just kind of move. You can move stuff around. All right? You just drag them and drop them. So did you guys jot that down? This is the critical part, and please write it down before you do it. And watch me. Question or yawn? All right. Just having a foreign key is not enough to establish relationships. We have to do this part also. Okay? So this is how you do it. You take the primary key and you drag it on top of the foreign key and let go. Okay, so jot that down. Take the primary key and drop it and drag it over the foreign key that it's related to and let go. So,
Repeat that one more time.
Yeah.
so you click on the primary key, hold your mouse down, and drag it over the foreign key in the next table and let go. And it'll make more sense when you do it. So you guys ready to watch? So, I'm going to click on University ID, and I'm going to drag it on top of Class University ID, because they're related, right? And let go. One more thing you have to do, and write this down, because some of you won't do it. Make sure you click the box, Enforce Referential Integrity. Very important. Enforce referential integrity. And of course, click Create. And that's what you will get. Instead of a crow's feet, Access shows you the infinity symbol, it shows you 1 to infinity, 1 to many. Okay? If you don't have that, you did it wrong. And if you did it wrong, watch this. You have to click on it just exactly in the right spot, and then hit the delete key, and it'll go away. So if you hose it up, click on the relationship and delete it. Okay? So I'm going to do it again. University over class university, and enforce referential integrity. Ta-da! And ditto for class over student class. Enforce referential integrity. Ta-da! There you go. That's it for relationships.
But it's not letting me do it. It says that the database, and you cannot log table class because it's already used by now.
Okay, very good point. So I want you guys to make a note of this. Always and forever in Access, close everything before you start the next thing. Does that make sense? So, if you've got tables that are open, close them. Because you can't make relationships until your tables are closed. So, anytime you go on to do something else, close everything. Okay? Or you'll get that error message. It's open. So, did you do it? Close everything? It worked. Good. Close your tables. And then go back to relationships. All right, so I'm going to close, and I'm going to say, now I have relationship. It doesn't show up here on the left, but they're there. They're there. Okay. Now draw a line, and we're going to put metadata, M-E-T-A-D-A-T-A, metadata. Metadata. So remember, metadata is just the background characteristics of the columns. Okay? That's all it is. The background characteristics. So let's go back and open the university table. So to open it, you just double click on it. That's easy. Double click on it. So you should jot down, double click on your table to open it. Okay? Double click on it to open it. And the default view is datasheet view. But this time I want you to add another step. Okay? This time we're going to change the view. So step 2, in the Home tab, at the top, in the Home tab, click on View, Design View. So step 2, in the Home tab, click on View, Design View. Design View. You're going to be in Design View a lot. So now we see the fields, but we see them a little bit differently. They're actually in like columns, okay? They're like in a list. But over here to the right is the metadata. And all this junk at the bottom is the metadata. So let's check things out. University ID. First of all, do you see that key there? What does that key mean? Primary key. And did you put that there? No. Access automatically decided that the very first field was going to be your primary key. All we did was typed over it with University ID, right? Okay. And for our purposes, it's always going to be auto number, so just leave that alone. But university name, short text. Go look at the bottom. the default length? How long should the university name be? I don't know. What's the longest university name? 60? I don't know. It's probably more than enough. So just type over it with a reasonable number. And this is where students go wrong a lot, is they don't change it, they just leave it 255. Okay, you get points off for that, so don't do that. Okay, that's it. That's it. All right, university website. It's short text, but again, it's field size 255. I think, hold on a minute, let me just look for fun. No. I thought that there was like a URL. I guess not. So, what's the longest website name that you think? How many characters do you think we need? I don't know. I'm going to go with 50. Just to be safe. Okay, that's metadata. See how easy that is? That's so easy.
So just to make sure for my notes, I go to field view, right, or that design view, then data type column, then I go down into the field properties and change the field size. That's all we need to change for each one of the rows inside the data type.
Almost.
Okay.
Now listen up, guys. Some of you have fields that are actually date. So I don't want those to be text, okay? So just for fun, I'm going to click on this down arrow here. These are the different types. Long text, number. Your foreign key is going to be a number, correct? Date, time, that's what you want. If it's date of birth, for example. Date of birth, that's good. It's going to be a type of date time. If it's money, you should have it as currency. IDs, like the primary key is always going to be auto number. Some of you have yes, no fields in your database where there's only one option, yes or no. It's the only answer. I have used this in the real world in the past as a default value. Like, if it's a date, I could put the default date in there so I don't have to keep typing it over and over and over again. But that, you're right. For the most part, that's it. If it's a text field, you have to go down to the bottom and fix it. Okay, right-click, save, right-click, close.
For address, you want us to do a new field for each part of the address?
Yes.
So, yeah. Zip code.
Also, any combined fields have to be separated. Address should be university address, university city, university state, university zip. Names should always be separated into first name, last name. And there are other fields that are commonly separated, and use your best judgment. Okay? All right, the next one, I'll let you guys move on to student and class. So open up student and go to design view. Student last name, I don't know, 40. Student first name, also, 30 maybe. Now remember, the foreign key must always be numeric because it matches the primary key, which is numeric. The foreign key has to be numeric because the primary key that it's put to is numeric. Numeric equals numeric, right? That's it. Right-click Save, right-click Close, and go on to Class and Design View. Class name, 30 maybe. And class university ID is already numeric. We just leave it alone. Right-click Save, right-click Close. So you'll notice that whenever I start the next thing, I always start with a blank screen. Save and close.